I'd like to show you first the articulator that's been made by the Advanced Dental Designs Limited. It's a new articulator. It's a precision instrument. It split cast checks to approximately 5/10,000ths of an inch accuracy. And each instrument is interchangeable with the other instrument so that models mounted on one articulator can be transferred to another articulator, the AD square, I call it the AD square, can be transferred to another AD square articulator, and they're exactly the same. Let me go through the different parts of the articulator with you so that you can begin to understand the articulator and how to use it. Number one, I like the articulator from the standpoint of it's very easy to handle, it's lightweight, and you have good visibility from the posterior when your models are mounted on the articulator, so you can see the lingual cusp very, very nicely, and also it can be photographed nicely from the lingual. We have the two pins in the front. The back pin is a support pin so that when the articulator's turned open like this, the back pin will support the top of the articulator. When you're working with the articulator, mounting the models, the upper and lower members must be parallel to each other. And this is accomplished by the marks that are on the front pin. If you look closely, you can see that there's a green line here. That is the zero line. That is, when that line is flush with the top of the articulator, that will put the upper member and the lower member parallel to each other. And that's the line that you should set up when you're mounting your upper model to the articulator. Set the green line so that you just barely see the green line, and now your upper and lower members are parallel to each other. This is a third reference pointer here. In some of the systems, when you're mounting, some of the face bows you sometimes are required to use a support here to record the third reference when you mount your lower model. That's the reason that this is here. This bottom of this, the third reference line here, is on the same plane as the axis of the articulator, so that you have your axis orbital plane. All models are mounted on articulators on the axis orbital plane. With the initial records that we take is done with a face bow. That's an estimated axis. Later in procedures on many patients, we must locate the actual hinge axis of the patient, and then we mount the models on the actual hinge axis of the patient. So they're all mounted, though, on the axis orbital plane. This instrument, as it is shown today, has a 1.5 millimeter analog. That is, I would use this on a patient that had a 1.5 millimeter immediate side shift. And these areas here, kind of like big rubber bands, activate and move the top of the articulator into the side shift. And at the same time, it holds the top of the articulator against the condyles. This is called a centric latch here. And again, when it's in place, it holds the top of the articulator down against the condyle balls. This is a little screw system that holds the centric latch open, and it works by turning it, and now then the centric latch will stay open, so that when you want to move to the sides, you would then move the centric lock, and the articulator now will move side to side, so that when you're checking the movement patterns of the patients, and you can see how the side shift is activated here, and the articulator then moves side to side, a millimeter and a half. Now, you move to lock the articulator in centric again, you move the centric lock back up into position. The centric lock is held in position by a small magnet inside this area right here. And that's what holds that centric lock up when you put it in place. Now, one thing that's very, very important, to put the centric latch back up into position, must push down on the centric latch a little bit and then pull down here, and that will release the centric latch, and you can put the centric latch back into position. When you pull it down, it locks it down, but you can't push it up without first releasing here. And to release it, you've got to take the pressure off and then release it. If you don't want this activated, then you pull this down and turn it a quarter of a turn. And now then, it does not hold the centric latch down. When you mount your models on the articulator, you want the upper and lower members centered over each other. That centering is done by your centric lock here. And then put your centric latch in place, and that's going to hold the top of the articulator against the condyles. Once you have actually done a hinge axis on a patient, you will be measuring the angle of the eminence, and that's adjusted in red here. You can see the degrees here in measuring setting the angle of the eminence. And you have to release 2 Allen head screws to set that here and here. And so we release those, and now you can change the angle of the eminence. When you're mounting models on the articulator, you want to have the angle of the eminence set at least at 45, and if you set it even a little steeper, that's okay. And what that's doing is that when you mount your lower model, it will tend to hold the condyle in the fossa box here, the analog. And we can get a good look at the lower member with our condyle balls here. And our incisal guide table is, and we can shift to the incisal guide table as needed. And the top of the articulator, from underneath, you can see now you can get a good look at your analogs here in the fossa boxes. As I said, this is set up to be a 1.5 millimeter side shift in the fossa box here. I'll put it back together again. And then we'll put the activators on. If you want to store the activator, I should point this out. If you take it off and you want to store them, there's a little hole here that will fit in. I want to center the top again, so I'm going to put the centric lock in place. The purpose of the test column is that as you use your articulator, you want to make sure that it maintains the accuracy. And the only way you know that is to have a test column, a split cast test column. Also, it's a possibility that one day you may drop the articulator. And so, again, if you drop the articulator or anything of that nature, you want to make sure of the accuracy of the instrument. So, okay, we want to put this upper mounting plate on, a metal mounting plate. And it fits very, very accurate. So you snap it into place and then use the large screw assembly here to lock it in position. And then we put the lower on. Again, it fits very, very accurately. Tighten it down good. And now with your pen, with the anterior pen, set it at 0. That is, so that you can just barely see the green line. That's the 0 measurement. This pen is calibrated. I should mention this. The pen is calibrated at 1 millimeter increments. So each of these lines, divisions, is 1 millimeter measurement. And a lot of times we talk about at +3 or -3. That means that the pen reading, the line here, for example, the red line is at +3. That when that red line is flush with the top of the articulator, what has actually happened is the articulator is open like this, 3 millimeters in the front. And so we would talk about a +3 measurement. In fact, I'll set it so you can see that. There. Now then, the pen is set at +3, so the front of the articulator from here to here is 3 millimeters longer. So it's no longer parallel. The upper part is not parallel to the lower. It's only when the green line is flush, just barely see it. Now then, the top and lower are parallel to each other, and this is the way you want to make your split cast, when these two parts of the articulator are parallel to each other. Just a piece of plastic that fits on here, like so. And we're going to put a little bit of separating medium on our split, on the metal split cast part here. Just a very, very, very thin coat of separating medium, such as maybe a silicone spray, or take a little Aquaphor and put on here, and then take a tissue and wipe off the excess. And then put this plastic ring on here, and you'll fill this up. You'll fill the entire part here with hard dental stone. Fill that up with dental stone. And then when it's set, take this off. And we'll show you this procedure in the lab a little later. Then put it on the upper member, and you'll pour dental stone in here. No separating medium now here. Pour dental stone in here and fill it up halfway, so that you'll have stone here, and then when this sets, you'll have dental stone here. You then will put the two together, and you'll have a very small space, about 2 millimeter space between the two stones here. You then take additional stone and add to it, so that you then end up with one piece of dental stone attached to the upper member here. And that then will have the male portion of these grooves here, and when you close the articulator, those must come together exactly right. And as I say, we'll see this in the lab a little later today, of exactly how to make this and how to split cast check. If you drop your instrument, you put your test column on here, and this doesn't split cast check, then you've damaged your instrument, and we must recalibrate the instrument for you. So it would have to come back to the factory for us to recalibrate the instrument for you. That's what is very, very important, because once it's damaged, it no longer matches any of the other articulators in the system. The mounting stand, I'd like to demonstrate that to you. If you look from the side here, you see that there's grooves cut in the back here, and it drops down into a little slot at this area. When you mount your lower models, you have to use your mounting stand to mount the lower model, and the way it works is like this. We would first set our pin here at our +3 measurement. Remember, we've already mounted our upper model here, and now we're going to mount our lower model. And I'm just demonstrating how the mounting stand is used. The area here, the activators of the side shift, this pin fits into this groove here on each side to support the articulator. Elongate the posterior pin on the articulator, and we're going to then put the articulator into the mounting stand. Notice I've approached it from the back, so that when I open the articulator, the upper member of the articulator is over the mounting plate, the mounting stand. And we would then put our lower model on with the wax bite on our upper model. We would adjust the back pin to make the model, top of the model of our lower model parallel to the floor, and now then you see that it's set so that it's nice and stable. The instrument doesn't rock back and forth, we put our mounting plate on, put our plaster on, and we close it like so. And that's the way we mount our lower model. You make sure your articulator is locked in centric so that the upper and lower members are parallel to each other when you do this. And then to take it off, you merely take it and lift it up and off like that. This is called an ear bow or an anatomical face bow or an estimated face bow. What this does is it will estimate the axis of the patient, and we will use the estimated axis to mount our first set of models. And I'd like to identify the parts of the anatomical face bow. Number one, this is the ear bow assembly here. And then these two areas here, this is the part that fits into the patient's ears. This is the orbital pointer, our third reference pointer, and then our two bite forks, and then the bite fork assemblies here, the Nasion relator, and then this is the incisal guide table that you use to actually mount the bite fork to the articulator, and we'll interchange this with the incisal guide table on the articulator. And this is a hex wrench that will tighten and loosen the toggles. Number one, when you start to use this, the large screw here will work the distance between the ear bows here. To use the pointer here, you must first loosen it a little bit, because this is usually very tight and very difficult to get loose. So work it a little bit like that, and then this screw will unloosen nicely. And you move this back away from the patient like this before you put it onto the patient. Now, we generally don't use the orbital pointer when we're doing the first mounting, that is the anatomical mounting. This is used when we're actually doing a hinge axis recording on our patients. So today, when we do the ear bow mounting, we will not be using the orbital pointer. Put it back in position here. This is the bite forks. We have two bite forks with each face bow. And you'll notice that the bite fork has a slight curvus V in the posterior area here. That will help when you close the patient into centric, so that the lower molars have less tendency to hit against the bite fork, and makes it a little bit easier in taking the hinge axis recordings on our patients. We have a series of holes in the bite fork for two reasons. Number one, you may be using the Panadent bite tabs, compound bite tabs, which will work very well on this bite fork. But in some areas, we don't have the Panadent bite tabs available, and we'll use the green stick compound. And we'll heat the green stick compound and push it, some of it through the hole here, and then flatten it on the other side to lock it onto the bite fork. So that's the reason that we have made our bite forks with a number of holes in them. The bite fork assembly has the toggles here and the hex wrench to tighten the toggles, like so. Again, you'll see this more clearly when we do this on a patient. There are two dimensions to the bite fork stem here. One is longer than the other, and when you use this on the patient, and if I'll demonstrate for a moment here, this this screw here is a thumb screw that you can tighten, and this fits into this assembly with the flat part must be toward the screw. The flat part toward the screw.
Show it to me. There you go.
And when you put it in, you must make sure that you put the proper end. This now must be flush with the top of the ear bow. If we put the other end in, you see it sticks out, and that's incorrect. So the short side is the one that fits into the ear bow. The flat side toward the screw, and then you tighten the screw to hold it in position. So it's like this when it's on the patient. We'll see this on the patient later today. Okay, we want to see how to use our Nasion relator. And the Nasion relator has a groove slot here which fits over the ear bow here. You approach from the back like this and slip it into the groove all the way, and now tighten it here. Now the Nasion relator has a round side and a flat side. The flat side goes up and against the screw like so. And we'll go in and out, and you lock it in position like this. Now when you use the large knurl nut here on the ear bow, just turn it about a quarter of a turn, and it will release and allow you to adjust the width. If you keep working it like this gets more loose, and eventually the screw falls off. So be a little careful in handling the ear bow that you don't move it excessively and have it fall apart on you. And so this is a way that you would have this set up when you get ready to work on the patient. And the Nasion relator moves in and out, and you then tighten it in position like that. And so that's the way that the ear bow works. And we take off the incisal guide table on the articulator and place our mounting table, and make sure it goes all the way back and locks against the back of the articulator, and then tighten it down like so. And now then we've changed and put the mounting table on. We then would put our bite fork stem here with the flat side again going toward the screw assembly. It would go all the way down, and the C-ring would stop against the assembly. That captures the third reference height, so that our model then is mounted on the articulator. Our model then would be mounted on the articulator on the axis orbital plane. And so that's the way the facebow assembly would work. And again, this becomes much more clear when we put this on a patient today, and you'll see it, everything done on the patient.
Stand by and go.
Okay, this is another part of the Advanced Dental Design's instrumentation. This I refer to as an MCD, MCD. And that stands for Measures Condyle Displacement. So that with this instrument we can measure in three planes of space the movement of the condyle from our centric relation bite to the centric occlusion bite. And that's the purpose of the MCD, is to make that measurement. And let's take a look at the MCD for a moment and how it works. We have these condyle blocks here. We'll refer to them, and you can see with the crosshairs. The center of the crosshair here is on the axis of the articulator. Very, very important. The center of the crosshairs here is the axis of the articulator. And if it'd be very difficult to see, but on the condyle ball here, right in the center of the condyle ball, is a small insert. There's a very, very small point on the end of this insert here, which again is on the axis of the articulator. So that the point here on the condyle ball and this graph paper, the intersection of the vertical and horizontal lines on the condyle block are on the axis of the articulator. And the same, of course, on the left side of the MCD. We have, again, a small point here on the condyle, and the graph is on the axis. So that these, if you projected an axis straight through here, these 4 points would all lie on the axis, which it corresponds to the axis of the articulator. And what you'll see later today, what we'll do is put a graph paper on here with millimeter measurements, and we would then be able to and put some articulating paper, and we can measure the actual displacement of the condyle from CR to CO. And you see this moves in and out very nicely here. And if we move it out, you can see that the pointer is right on the the crosshairs of the graph, the vertical and horizontal lines of the graph. Now we have to also measure the displacement of the condyle in a transverse. This measures the displacement. This measures the displacement in a posterior or anterior plane and vertical plane. But we have to also measure the transverse measurement. And so to do that, this posterior plate will measure the transverse measurement. And first, we have a little protective cover on the pointer here, and I'll take that off. And again, at the end of this projection here is a very, very small point. That point, again, is on the exact axis of the articulator, and now then we have 5 points that would line up exactly on the axis of the articulator. If I projected a line through here, it'd be the point here on the condyle, it's the center of the condyle, the intersection of the vertical and horizontal lines, and the point on this projection here. These are all on the exact axis of the articulator. And if we want to measure the transverse measurement, then this plate, we put a graph paper here, and we lift it up, and we would mark the actual displacement of the condyle in a transverse plane from CR to CO. And this locks down for protection. This would lock down just to keep the plate locked down so it doesn't fall off. Now, this is a column merely as a support column. Actually, it's made so accurately that it does come out so that it hits right on the vertical and horizontal lines. The condyle ball does, but it's basically a support column is all. Let me show you now how this will work also. If I were going to be using this on a patient, of course our support column won't be here. So we'll take it off. Now, number one, if we take a look now at the lower member of the MCD, it looks like the articulator basically. But again, if we can, I don't know if you can see how the insert on the condyles here, and there's a little point right here that's on the axis. Now then, when we're going to use this instrument, we want to put our graph papers on, so we'll put a very small amount of lubricant here and then take tissue and wipe it off. And I like to use Aquaphor to do this and it'll wipe off very nicely. And these arms here are made merely to support the instrument on its side like this so that you have good control as you put your graph papers on, because the graph paper has to be put on very accurately. There's the crosshairs on the graph paper, and that the center of the crosshairs has to correspond exactly with the crosshairs on the condyle block here. And so that's the reason we want something that's very stable and very easy to get our graph papers on accurately. And again, later today we will be putting graph papers on and doing the measurements on an actual patient.